Hello, everyone. Welcome back to the channel. I'm Pat at Maendeleolab, and today we are deploying the AWS Transit Gateway to the infrastructure that we are building. This is one of my favorite services in AWS. Let's go over to the graphical design. This is the infrastructure that we're building, and today we're adding the Transit Gateway. So here we are at the command line. I want to take a step back and go over to the Transit Gateway. So here we are in the Transit Gateway folder. The very next thing I want to do is first time my script, and we are deploying the US East 1 Transit Gateway. So now we are building the Transit Gateway to build route tables, attachments. What we'll do is go over to the console. So here we are in the console. I'm going to come down to Transit Gateway. The Transit Gateway is now available in US East 1. Very next thing should be the route tables. As you can see, the route tables are being created. It's in pending state. We've created a spokes route table. This is where we will associate all the VPC spokes. They will be associated to the spoke route table. The inspection VPC route table will be associated with the inspection VPC right here. And the VPC egress, this one will be associated with the egress VPC. So let me refresh. Okay, one has become available. Oh, they're all available now. Now, the very next thing after this is creating the attachments. As you can see now, it's already one attachment is being created. We are creating an attachment for customer VPC 1, customer VPC 2. We're creating an attachment to the inspection VPC, and the last one to the egress VPC. Right, as you can see, the state is still pending. We are still building. And we have an attachment to all 4 VPCs. And the best way I can explain this from a traditional network perspective, an attachment is really logically like a cable. Right? Think of an attachment as a cable between a VPC and a transit gateway. You can only associate one attachment to one route table. You have an attachment. Now this attachment needs to be associated to a route table. Then what you do, the VLAN can be the route table. So once the VLAN knows how to, whatever the VLAN knows how to get to, applies to the attachment. If your switch port is accessing a VLAN and that VLAN has connectivity to the internet, all those attachments associated to that particular VLAN would know how to get to the internet. The same applies here. So all your associations to a route table, whatever that route table knows how to get to, your attachment will know how to get to that specific route as well. So let's refresh. Let's see, now it's available. I see green. Now we can explore the route tables. So we'll start with the VPC spokes route table. The associations here should be the customer VPCs. These are the customer VPCs attachment. We can quickly double check that. Let's go over here. You can see this is the attachment for customer VPC number 2. And here you can see this is for customer VPC number 1. So these are associated to the spokes route table. And next, we have the inspection VPC route table. It's only associated with the inspection VPC. We can quickly check that. You can see inspection VPC is attached. The next is the egress VPC. Association should be the egress VPC attachment. We can verify that here. As you can see, the egress is associated to that route table. And after we associate the attachment, we have two choices. You can propagate an attachment to the table, or you can reference a prefix list. But for propagation, you can propagate an attachment anywhere, anywhere you need to. This is the default route to get to the internet. For the private subnet, you can see that we have the public subnets, static black hole. So we're making sure that the public subnets here do not communicate to on-prem or to the private network. So we've added these routes to make sure that any traffic source from the public subnet cannot communicate with private networks. So we do have routes to the private subnets of VPC number 2. This is VPC, customer VPC number 1, public subnet that are using static black hole, and the private subnets, we know how to get to those from this route table. And the way we get to the private subnets, we are making sure that the very next hop for this route is the inspection VPC. As you can see. So this is allowing us to perform inspection. As traffic leaves customer VPC 1, targets the Transit Gateway spokes route table. The spokes route table has a route to the private subnet of customer VPC number 2, but it is sending that traffic to the inspection VPC attachment first for inspection before it is forwarded to the private subnet of customer VPC number 2. So that's the flow of the traffic. And this is how we're making sure that we are performing inspection for VPC to VPC traffic. And if I go back for the default route to the internet, this attachment is referencing the attachment to the egress VPC. So this traffic is not subject to inspection. It is routed to the internet through the NAT gateways. So that is the setup as of now. Now, the very next thing we need to do is finish up the routing, making sure that we tie all the pieces together, making sure that routes are there. And this is what we'll do from the command line first. So I'll come here and I want to pivot to, I want to switch to the routes folder. This is a route that I want to deploy. And again, we'll go into details when we do the wrap up. Don't you worry, I will talk more about the code itself, the scripting process. I will give you more details on what I'm doing on the back, behind the scenes to get all that stuff put together. So I'm timing this. This is going to create routes. And again, this is returning true that is actually creating the routes. Let's go to the console. All right, how we verify this, we're going to start from source to destination. First thing is going to the route tables. This route table, let's look at the customer VPC number 1. We know that for the public, it's really simple. It's a default route to the internet gateway. And then we have routes for the VPC peering, right? This is for these subnets to communicate. They have a route pointing to the VPC peering to communicate with the subnets in the other VPC. For the private, this is also very simple, just a single route default pointing to the Transit Gateway. Back to the design here. So there's traffic there pointing to the Transit Gateway. So it's pretty much the same for network dev 2, which is the customer VPC number 2. Same, nothing different from customer VPC number 1. I think this is still being created. Let me refresh that and look. All right, here we have the default to the Transit Gateway. I'll come back here. This is the private subnet for customer VPC number 2, pointing to the Transit Gateway. We do the egress. This is the egress VPC. Egress VPC public route table as a route for the internet gateway. Then, as we covered over here, let's bring that back. So we covered here, the return traffic, it's only to the private subnets of the customer VPC. And this is what we have here. The customer VPC routes are there. This is for customer VPC 1, availability zone 1A, 1B, customer VPC number 2, availability zone 1A and 1B. And the target is the Transit Gateway. Now here, for the egress, we have a route pointing to the NAT gateways, right? The private is pointing to the NAT gateway. Same thing here, we are pointing to the NAT gateway in availability zone 1A. And now this is the inspection VPC route table, starting with the route table dedicated for the AWS network firewall interfaces. Here, the routes, very simple. It is targeting the Transit Gateway. So from here, these subnets are targeting the Transit Gateway. And we have two sets of route tables, starting with the first one for availability zone 1A, pointing to the endpoint, which is the AWS network firewall interface. And when we deploy the AWS network firewall, it creates these endpoints. And you can find those under network interfaces, under EC2, the endpoints. Let's just copy that. All right, so these are the VPC endpoint of the AWS network firewall that we're using. So each of the availability zones for the Transit Gateway are pointing to a specific endpoint in each of the route tables. So here, this is 1A, and 1B is going to be a different, it's going to use a different VPC endpoint. And this is how we able to achieve inspection. Traffic sent to the AWS Transit Gateway sends traffic to the AWS network firewall using the Transit Gateway route tables. AWS network firewall inspects the traffic, then sends it back to the Transit Gateway using the firewall route tables. This should wrap it up for us. This means that now we've established the routing, we've established everything that is needed for this central infrastructure. Now we have built a centralized architecture in AWS. All the details are there. We have built all of this using scripting. Now the very next step, network performance. We need to validate that this infrastructure is working as expected. We're going to validate traffic through the inspection. Each of these attachments can do a maximum MTU size of 8,500 bytes. Another thing, it can do up to 50 gigabits. I don't think we'll hit that based on some of the instances that we're using, which are T2 macros. They're not going to do that much speed, but we'll try to stress it as much as possible just to show to you how much you can do. even if you were to use T2 micros, right? Small instances. But the goal here is for us to also create traffic generators that we can create. We can use CloudWatch. We can use different tools to validate how the network is performing. So this wraps it up for today. And again, hopefully you find this informative. If you have any questions, please add it to the comment section. I am Pat at Maendeleolab. Let's research and develop